Right. Hello, Julians. James teacher here. Today, we're talking about everything you need to ace science in one big fat notebook. And we're talking about page 60 to 61, matter properties and phases. Specifically, we're talking about right here, matter and atoms. Okay, so let's define some of these key ideas first before we jump into some interesting experiments, thought experiments, if you will, with Santa Claus. So first of all, most important thing is to figure out what an atom actually looks like. So an atom is composed mostly of about 3 different parts. Let's take a look at the workbook, and we can actually start to define these key terms. So when we take a look at the notebook, we'll see that we have these 6 things. Now, matter basically is referring to everything. Matter is everything around you, everything that can be touched. That is essentially matter. Everything you see and can touch in front of you is essentially matter. So this gigantic triangle, let's say it's a pyramid, now it looks like this at the Opera House. This is made of matter. Everything is made of matter. Now, atoms are the smallest pieces of matter that we can detect, essentially. So think of it, tiny little dot. Everything is made of matter, and matter is made of atoms. Now, an atom usually has, if we just expand this a bit more, it has protons. Let's give this 3 protons. It also generally has, not always, but generally has neutrons in the center. Now, think about the neutrons. The neutrons are neutral. The protons are positive. Now, the neutrons stop the protons from repelling each other. It's kind of like the walls in a house holding the house together. So we have protons, which are positive. We have neutrons, which are neutral. And in a very simplistic way, we have these negatively charged electrons circling around the outside. So when we have these things all together, it starts to look like the standard model of an atom. Protons and neutrons in the nucleus, which is the center, and then the electrons swirling around. Okay? Now, protons, really simple. Let's think about a proton. A proton is basically a massive part of any atom. It's positively charged, which is important. Later, you'll see why. And it sits right in the middle of every atom. Now, basically, protons decide what the atom is. So, for example, if it has 1 proton, you're looking at a hydrogen atom. If it has 7 protons, it becomes a carbon atom. The protons can be different, and depending on the number of protons, that gives us the element that we're talking about. Now, electrons. Electrons, as we mentioned, basically are zooming around on the outside. Let's make them red, why not? So the zooming electrons zoom around. Let's give it 7. Okay, so we can have a carbon. Okay, right. So these zoom around. Now, they are too fast. It doesn't actually look like this. You can't see individual electrons. They move far too fast. So rather than thinking of this as like individual little things, just think of it as a cloud. It's a cloud of swirling electrons swirling around the outside, okay? That's basically one of the things we think about. Now, usually they have 2 little orbits. So you'll have the outer and then the inner orbit, okay? Now, we also have neutrons. As we talked about, neutrons sit in the nucleus of an atom next to the protons. And basically, these guys, they're neutral. They don't care. They don't have any strong feelings either way. They're just pretty stable, nice, calm individuals. And they just sit there right in the middle, okie dokie. In here, we have 3 protons, 3 neutrons. We have an equal number. But that not always the case. For example, if we talk about hydrogen, hydrogen has a proton and it has an electron. That's it. It doesn't even have a neutron. But neutrons are very important. Now, the nucleus basically refers to the middle where we have our protons and we have our neutrons, okay? So pretty simple stuff, not too complicated. Of course, it's exceptionally complicated when you get into more detail. But that's the basic premise, okay? So matter is the stuff that makes everything around us. Atoms are the smallest forms of matter that we can see. Protons, electrons, and neutrons are particles within atoms. Remember, protons are positive, electrons are negative, neutrons are neutral. And the nucleus is this bit in the middle, like the middle of the birthday cake, with all of the juicy stuff inside. Okay? Now, really important to remember, electrons can move. They can jump onto other atoms. And this is one of the basic ideas, that electrons are attracted to protons, but they're also attracted to other protons. A little bit like somebody's in a relationship and they love each other, but then they walk down the street and see somebody gorgeous, and then they say, you know what, I've decided to ditch you. Our relationship is over. I'm going to go and pursue a happy ever after life with that person over there. Electrons will abandon you. Now, if we continue, we get down to some interesting questions. Now, at this point, we will not abandon science, but we're going to do something a bit more interesting. We're going to think about, okay, how can we apply some basic knowledge? We haven't expanded our knowledge yet, but that's cool. We're going to expand our knowledge, and we're going to speculate with this knowledge, okay? So we're going to think about the basics. We're going to think about our atoms, we're going to think about matter, we're going to think about protons, neutrons, electrons, and we're going to play around with it. Because one of the great things about science is we don't want to get bogged down with, right, okay, let's go and answer some boring questions. No, this is Jool. We don't want to do that. We want to answer some interesting questions. So we're going to pose some questions about Santa Claus, okay? You have, in the link below, and also in the book, you will see there's a link to a fantastic video on YouTube called How Fast is Santa Claus, which is brilliant. I highly recommend you go and check it out, where this guy breaks down the mathematics and the physics behind Santa Claus, okay? But we're going to simplify things, but we're going to have a little bit more fun, a little bit more creativity. Now, the first thing we're going to talk about is how could Santa travel at 650 miles per second? How could he travel? Now, obviously, he has some problems, right? He's got flying reindeer, but I guess if the reindeer are flying and his sled is flying, then we can be a little bit ambitious here. We can think about, okay, maybe it's a slightly magical scenario. Slightly magical scenario. Well, here's something kind of amazing. Now, if we think, firstly, that Santa Claus actually has some rather special abilities. So he can use something called quantum manipulation. And if he uses quantum manipulation, he can basically shrink himself. So as things move at a higher speed, they require less, or their mass increases, right? So as they get faster, their mass increases. But if he could shrink his mass, make himself smaller, he wouldn't require so much energy. So if we have big, jolly Santa Claus over here, and then he's got a big green beard, and then we could shrink this dude down. Oh my goodness, it looks like a cow standing up. But if we could shrink him down using quantum manipulation to just be about this big. In fact, he's so small, we can't even see it. We can just accept his beard right there. If we can shrink Santa Claus down, he requires far less energy to move. So a little bit of quantum manipulation would help us to do this. Now, just to help you understand, 99.999999% of atoms is just empty space. So inside this atom, most of the space is taken up by this cloud of electrons, right? So if we could take Santa Claus's atoms, and then we could shrink him down with quantum manipulation, if we could just almost dehydrate his atoms and get rid of the empty space, then suddenly we're not moving a human-sized magical center. We're moving around something the size of an atom. Now it gets really interesting, because if we can do that, we could consider the idea of ionizing Santa Claus, turning him into something like pure energy particles. Now, pure energy particles, well, the best way to think about that is light. If we can turn Santa Claus into pure energy, well, then he can start to move at a very, very sedate light beam speed, which is 186,000 miles per second, not 650 miles per second, 186,000 miles per second. Now Santa Claus is, he's laughing all the way to the bank. He could do his job with time to spare. This is one idea. Another idea here we could use is if we get a little bit relative. Now, this is, after all, a magical, laughing Santa Claus kind of guy. Well, if we use a little bit of relative physics, or relativistic physics, well, then we can change the way we think about this, right? So at the moment, the laws of physics and the universe basically dictate everything, right? Santa Claus, we exist within the laws of physics. But how about, because he's so magical, how about if Santa Claus is able to actually move space and time? So he has the power to actually move the universe around him rather than him moving around the universe. So a little bit of relativistic physics would allow Santa Claus to just ignore the rules of physics. He wouldn't have to worry about protons being fixed and all these kinds of things. He would be able to do whatever he wants. So that's the first question. Now, second question, if you're still with me. Second question, how could Santa's reindeer not get turned into plasma? Well, oh my God. Well, if Santa Claus is moving at 186,000 miles per second, he's got a bit of a problem because his reindeer are going to be heated up to such an extent that they're probably going to be turned into plasma, which is obviously not ideal because they're pulling the sleigh and they're animals, and we care about animal welfare. So we don't want them to turn into plasma. Now, what are we going to do here? Well, they are, after all, made of the same stuff that everything else is made of. They're made of matter. So how can you protect these reindeer from getting turned into plasma? Basically, gloop. They're going to get turned into high temperature gloop. Well, you could use something like a deflection field. Think about space rockets and space shuttles. When they return to Earth, they have to have this space, this shield against the air resistance to protect them. It's got a very long name, but it's also all to do with, it's called magnetohydrodynamics. Go and Google that when you have 5 minutes on the toilet. But basically, we could fit the reindeer with these kind of suits, a bit like an Iron Man suit, but a reindeer version with the little space for the antlers, protecting them from the incredibly high temperatures and all of the flies getting stuck in their eyes and stuff like that. Of course, another idea is that, well, since Santa Claus is actually obviously not human, he could actually, along with his reindeers, be made of dark matter. So they may, in fact, actually be dark matter. They may be the antimatter of the universe, which means that they don't have to follow the rules of physics. They can do whatever they want because they are not made of atoms with a nucleus of protons and neutrons and swirling electrons all the way around. They're made of something else, which we just can't understand, which is a fantastic idea to think about. Now, okay, let's move to the next question. How could Santa Claus not kill everyone by dragging a supertanker of presents around and landing on people's chimneys? I mean, let's just kind of think about this. How many children are there in the world? Well, if we, I don't know, take the population of a country, take the population of the UK, it's about 80 million. And then we say, I don't know, about 20% of people in the UK are kids. It's like, wow, okay, now we're talking serious numbers, right? So let's go on the world scale. Let's say that there are, I don't know, 8 billion people. And then 20% are kids. Oh my God, that's a lot of kids. So we can't have Santa Claus carrying around this super tanker full of presents, all just smashing into stuff and wiping out towns, murdering everybody in the name of Santa and Christmas spirit. So we need to do something else. We've got to figure something out here. Well, using physics, we could enter the quantum realm, right? Because of course, remember we said that atoms are made of protons and neutrons and things like that. But we can go smaller than that. We can say that basically protons, which again are the building blocks of everything, actually are made of something called quarks. And gluons. Now, gluons basically are the things holding it together. I like to imagine the rainbow bridge from Thor, the Thor movies. But basically, quarks are these tiny little things, and gluons hold them together. Now, these are kind of within protons, within these particles. So now, if we use a little bit of quantum manipulation, and basically, like we said before, you could reduce the space between atoms or inside atoms, and you can reduce the space between quarks, and you can shrink yourself down like Ant-Man, then basically we could use this idea with these presents. You shrink down the presents with a bit of quantum manipulation into tiny, tiny atom-sized presents. And all Santa Claus has got to do with his little gadget is just kind of bring them back to size when he arrives at the house. And it's easy peasy. He just kind of flips it out of his pocket and like, okay, there's your present. Boom. And remember, he's doing this all at 186,000 miles per second speed. So, I mean, it's hardly going to be a challenge. You wouldn't even see him. He's going to be moving faster than light. So he's literally going to be there and gone before you even can scratch your butt. So we've got that. That sounds like a pretty reasonable answer to me. Of course, we could do something else. Because we could actually say that Santa Claus does not, in fact, actually move through the air. He's not this big ball of atoms bashing into other balls of atoms like you and I. In fact, he doesn't do that at all because he doesn't move in the same way. He basically teleports. So basically, if we consider Santa Claus, perhaps he's creating wormholes through space, popping out in your living room, dropping off this quantum manipulated present. He basically flips a switch. It comes back to the normal size as it was. And then he dashes off again, back through his wormhole to the next house. So maybe he doesn't even need to fly. Maybe he doesn't even need this 186,000 miles per second super speed because he just goes through wormholes. He rips open the fabric of time and space. He rips open the atoms and peers inside in the fourth dimension, and then he goes off and has a great adventure. So let's go to our next question. Wow, this is getting interesting. Now, how could Santa fit through chimneys despite his rotundness? Well, this is pretty simple. I think we've kind of covered this by now. There's a lot of empty space between atoms. Well, he could shrink himself down. He could use a little bit of quantum manipulation, or he could just rub himself in butter and slide down without any friction. Now, that brings us, of course, to the final question. The final question is all about you. The final question here is, well, okay, we know what Santa Claus can do. He's magical. He's absolutely magical. He can do all kinds of different things. But the real question is, how about you? What can you do? How can you basically complete the following task? How could you take the ideas here and finish school and university to a PhD level? That's 23 years of education. Becoming Dr. whatever you want to call yourself in 3 weeks. We want to go a bit faster than usual. At Jool, we always talk about 2 or 3 years ahead of school, but no, we're talking a 23-year education in 3 weeks. Well, it is mathematically possible to compress 23 years of learning into 3 weeks. But it would require an unreal amount of study time per day. So here's the breakdown. Years to days. 23 years is roughly 8,395 days. So we've got that's what we have to play with. Now, days to hours, assuming an average of 8 hours of study per day, that's 67,160 hours of study. So we've got to get that into 3 weeks. Now, hours per day in 3 weeks. To cover that in 3 weeks, this is where it gets a bit tricky. In 21 days, you need to study for 3,198 hours per day. Now, what are we going to do? What are we going to do with this? How can we actually figure this out? Well, that's up to you. That's up to you. I've displayed my strange creativity with the previous questions, but now it's over to you to figure out what you're going to do. Are you going to use some quantum manipulation and shrink down your atomic size? Don't know why that would help, but it might make things a little bit easier to hide. You could also turn yourself into, you could ionize yourself, turn yourself into light particles or light energy and beams, and you'll be able to do everything at 186,000 miles per second. I mean, you could do a lot of writing in that amount of time. You could start, if you could travel that speed, you might be able to start ripping some holes in space. You might be able to go faster than light. Then you might be able to start to develop some wormholes through time. So, I mean, one idea here is possibly you could basically go backwards in a cycle. So you do some work, you study, then you rip open a wormhole, travel beyond the light speed, go back in time 3 weeks, and repeat the cycle again. So basically, you could live 23 years in unlimited loops. That sounds pretty interesting. I think Flash did that in one of the pretty rubbish DC movies. So there we go, guys. Now, I hope that helped. helps, okay? Hope that helps. It may not, but remember, the point here is that you guys right now are studying simple atomic physics. So the ideas I'm talking about, the other things I'm talking about, are just to show you that you can kind of go off in different directions and think beyond this. Don't be limited by the pages in the book, okay? Really try and experiment and read further and think of some amazing ideas. Okay, guys, I hope this helps. Now, if that was helpful, continue. Write down your answers, do your homework, send it to your teacher. If anybody listening to this video is not a Jool student, well, check the link below and become a Jool student. Of course, why wouldn't you, with such incredible videos? But apart from that, I will see you guys next time when we talk about the next subject. Bye-bye, guys.